So, where are you on this prototype?
So, we've been working a little while with the gripper mechanism. We've posted 1 or 2 videos about how this arrangement works. You've probably seen this setup before. It's got the one side, this right side, my right, fixed over here. This other side can articulate in and out. And we're using the rough top tread to grasp the totes and the recycling containers. What we found with this was that it picks up the totes extremely well, I think. No problems at all with the totes. Maybe still some work needs to be done for the recycling containers. We're still seeing a little bit of that give we were talking about earlier, where even when we would grab the recycling container within this circular area, it would still kind of shift back or forth, and you can probably see that in one of the videos that we posted.
Okay. So I do have a question for you. So there's the grooved edges, right?
Mm-hmm.
For the kind of the recycling bin to fit into. Did you always have grooved edges in there? Did you test straight edges or maybe any other ideas?
Right, we did test a couple different variations of the straight method. So basically just like a forklift where they'd be stationary. Also where it was potentially spring-loaded. So we didn't actually test it with actual springs, but we discussed the idea of you'd go into it and then the tension from the springs would hold it tight. Let's see, what else? Did we have any other options?
I think those are the main two.
Those were, yeah,
kind of an active gripper or some kind of maybe a passive gripper. Maybe a similar idea to this, but with kind of a spring on there.
Yeah.
This design specifically, the one you're looking at, this is its 2nd or 3rd modification. Originally we had it just with a straight edge up and down here without this indent here. And what we found was still picked up the totes extremely well, but up really high on our priority list was picking up those recycling containers. And unfortunately, that give that we were talking about, that in and out, was extremely bad with that. Like, you're probably going to lose the bin just because all you have is you've got 2 points of contact then, and it's just pushing in really tight, and the recycling container can very easily torque one way or the other, and there's not very much to stop it, unless we did get it to stop if you squeeze it extremely tight. You just squeeze all the air out of it, but I think we're probably not going to be wanting to do that in a competition unless we have to.
Yeah, one thing we did notice though is if we could grip it under the handles of the bin or the recycling container, or just under the lip, kind of around that handle area, we were able to control it fairly well, just from the tipping perspective, and also just being able to grip it. So that would be one option we would have. One thing that we don't necessarily like about that is we would have to grip it higher, and that would kind of affect our height of our robot and things like that. So that's what we're looking at.
Another thing with that design is it would likely make it much more difficult to pick up the totes, which, you know, it might be a compromise we want to make, because picking up the totes was only 4th on our priority list. It wasn't one of our top 3 where we drew the cutoff line. This is what we absolutely need, but, you know, I don't think anybody's disagreeing that it would be nice to pick up the totes. So I think that's where we're at then, is we have the 2 choices for those 2 kind of designs. We have this design, or some variation of this, where it's an active gripper. You know, obviously, well, we may articulate both sides in the final design, and we'll have it look a little bit nicer and perform a little bit better. But something like this, you have an active gripper with probably an indent on both sides, so it can pick up both the recycling containers and the totes fairly effectively. The other option we were looking at was something maybe similar to this, but now instead of actively with a piston, for example, pulling this in and out, you have maybe a spring down here or something that just kind of passively holds it in. And what you can do with that then is that you could pretty reliably pick up the totes just with no other active mechanisms at all. So you don't have to worry about a piston or motor or something. And I love passive mechanisms like that, where you don't have, you know, it's one less point of failure for it to go with. But the disadvantage to that would be, like was said earlier, you probably raise your height that you need to grab the totes by, because you need to grab them by the lids instead of any arbitrary point, and also that it likely makes it harder to pick up the totes. So I think that's about where we're at.
All right. Well, I think you guys answered all of my questions. Do you think you're going to move forward with this design then?
Good question.
I like the passive design, but that's me.
Well, you don't necessarily have to know what you're going to do to bring them in and out yet, but do you think this grabber is going to work?
I think this grabber is good. I think it just comes from the distinction of, are we going to be grabbing it from the sides, you know, in which case we would definitely use something like this, or do we want to kind of get underneath it and prop it up, more of like a forklift kind of a thing. And we tried that without the rough top, just with the wood, and that worked really well. You know, it's just, you cut out the indents and it just kind of slides right on, and it just kind of rests on this wood edge right here. And you don't need nearly the force you need for the grabber to hold it in place. It's just very, you could, in theory, get by without any force. You know, it's just resting right on top of there. But we were thinking just maybe some little springs or something to hold it there. So.
All right. Well, thank you guys so much for your thoughts and opinions on that. We look forward to see what you come up with.
Thank you.
Thank you.